When it comes to integrations by substitutions, there are two extremely important theorems. While those two theorems are not required to solve any questions with integrations using substitutions, the use of those two theorems will significantly save your time. In this video, I'm going to discuss the first of those two theorems, along with the complete proof and two examples. So here's the first of those two extremely important theorems. Let's say you have to evaluate an integral of this form. Integration f of x raised to the nth power times f prime x dx, where f prime x is the first derivative of f of x, that is irrespective of this power n. You just have to differentiate f of x. If you can see this pattern, the answer of this integral will be equal to f of x raised to the n plus first power all divided by n plus 1. And as you can see, this theorem is applicable only if your n is not equal to -1. We will see the proof of this theorem real quick. For the proof, we are going to let u be f of x. Then du will be equal to f prime x dx, where f prime x is the first derivative of f of x. Now we can write down this left hand side of that theorem, integral f of x raised to the nth power times f prime x dx, as integral f of x to the n. F of x is equal to u, so this can be written as u raised to the n, and then f prime x dx, this part right here, is equal to du. Therefore, I'm going to write this as u to the n du. We know this is a result found in the standard table. It should be equal to u raised to the n plus 1 over n plus 1. We know this holds true only if your n is not equal to -1. Now we need to go back and keep the answer in the original variable. That means I need to replace this u with the corresponding x. U is equal to f of x, therefore this becomes f of x raised to the n plus first power all divided by n plus 1. And that holds true when n is not equal to -1. So this is an extremely important result in integrations using substitutions. We will look at two examples. So here's the first example. I need to evaluate the integral x squared 2 plus 5x cubed raised to the fourth power dx. To evaluate this integral, traditionally you may use a substitution such as 2 plus 5x cubed equals u. But with the previous theorem, I don't need that. I can see this part as f of x and this as n. So my f of x is 2 plus 5x cubed, n is equal to 4. So if I differentiate 2 plus 5x cubed, I know my answer should be 15x squared. What I don't have is just a 15, because right here it is just x squared. So I'm going to rearrange this question as integral 2 plus 5x cubed raised to the fourth power. Instead of that x squared, I'm going to write a 15x squared. Because I introduced a 15, I'm going to divide that out. And then I have dx. Now, nicely, this is my fx, this is my n, and right here I have f prime x. So the solution can be written as 1/15th times f of x, which is 2 plus 5x cubed raised to the n plus first power. N is equal to 4, so 4 plus 1 is 5. All that divided by 5 plus c. Of course, this can be simplified some more. 2 plus 5x cubed to the fifth power, 15 times 5 is 75 plus c. That's the solution. Let me also discuss one more example with that theorem. So the next example is integral sine fourth power 3x times cosine 3x dx. To evaluate this integral, I can see sine 3x as my fx, 4 as my n, and then for f prime x, I need cosine 3x times 3. That is because if you differentiate sine 3x, you get 3 times cosine 3x. Well, I don't have a 3 right here. Therefore, I'm going to create a 3 as 1/3 times integral sine 4th power 3x 3 times cosine 3x dx. Now, right here is my fx, n equals 4, and right here I have f prime x. The solution should be, there's this 1/3 outside, f of x, which is sine 3x raised to the n plus first power, n equals 4. So it is raised to the 5th power, all divided by 5 plus c. So the final answer can be written as sine 5th power 3x, all divided by 15 plus c. Alright, so try to remember this theorem. It's extremely important to save time for you when you're doing a question like this in a timed exam environment. There is a second theorem also, just like this one, that is the case when n is equal to -1. Make sure to watch that video as well.